Okay. Alright, well, there are a lot of instructional videos on how to program, but one of my friends is having a little trouble with it, so I thought I'd make this and try and help him out a bit. If anyone else gets any benefit out of it, it's good for them. He wants to learn how to make video games. I happen to be a computer science student, and while it's not exactly a requirement of the field to make video games, if you are a computer scientist, it should definitely be something you should be able to do. So here we go. One of the first things you're going to want to do is get yourself a compiler. What I like to use personally is the NetBeans IDE. This is a version of 7.2. You can get to it by pretty much just going to the website netbeans.org, hit the little download link. The version that you're going to want is this all version because we're going to be starting out in C++ and then shifting into Java because I don't know, that's how I figure we're gonna work this out. So you can probably just pause. I'm going to, well, obviously pause while you download your compiler. I'm going to continue right now with just a little bit of a brief explanation. Coding can be sort of, I guess, not exactly separated into three parts, but we're going to separate it into three parts for the purpose of the lecture. There's the compiler version of the code, which is what you will see we will be writing our code in, and that's what a lot of people generally see. There's assembly code, which is sort of an easier implementation. It takes the compiler code, and what the compiler does is it transfers it into assembly code. Assembly code is a lot easier for the machine to understand. I'm probably not going to go into exactly what assembly code is, but it's in existence. And then once the program is in assembly code, it runs through an assembler to perform, to become machine code, and then machine code is what the hardware of your computer actually executes. So there you go, sort of step one. Moving on to the actual NetBeans programming part of the situation. Is it loading up? Yeah, it's loading up. Hopefully you didn't need this diagram anymore. I'll be rewriting over this space, so. Wow, this is running slow for me. Hopefully it works out a lot better in post-production, but who knows. Is it up? Still working on it. Alrighty then. NetBeans sort of takes a little bit to start up, but once it's started up, it normally runs pretty fast. My version might run a little bit slowly because I'm recording a screenshot of my computer, so obviously more things going on for it to take note of, the slower each sort of system gets, which hopefully means this video will be of like the actual recording image will be fine. Cross your fingers. If it's not, we'll consider this a test run. I think this is test run version 7 or 8 by now, but yeah. Okay, good job, NetBeans. You're up now. Alright, so this is the start page of NetBeans. I'm not going to really run you through how to use NetBeans because that's not the purpose. This button here is the Add New Project button. Whenever you're choosing a new project, it actually lets you pick the category, well, no, not category, the language of code that you are using. NetBeans, I think I've said previously, you can use C++, Java, and there's a PHP option, but PHP's not really applicable to our situation that much, so we're just going to sort of ignore it. Why are you... Okay, so it's just being super slow. You exit out. Hmm. Here, oh. That's not what I wanted to do. Okay. So hopefully you will ignore that little mishap. Makes me look a little like I don't know what I'm doing. I swear this doesn't normally happen. Bet a lot of people hear that a lot. Anyway, so once you choose your category of project you're working on, we're going to be working with C, C++, and you're going to want to pick the application sort of situation. The C++ project from existing sources and from binary file are mainly for way into the future, like sort of past where you'd be getting in. So it's not really, again, not applicable. Might cover it later, probably won't. I'm just going to name this lesson 1. Certainly seems pretty fitting. Create main file. Normally this depends on what type of experience you really want. We're going to use just for ease pretty much. We're going to create the main file already. It's called main C++. Finish, and we'll load up our project. Doop-a-doo-doo. Okay. So they have NetBeans has these little collapsible boxes to sort of to organize your files in different test subjects. Main CPP is under source files. It's what we're going to be starting out and using. We will get into what header file and resource files are in subsequent videos. For now, you can put it off in the back of your head. It's going to come up eventually, but for now you don't really have to worry about it. Sort of starting out for the actual programming, pre-situation is, you'll see here these are gray. Grayed out lines mean they are comments that you can actually make. So the compiler doesn't try and execute these. This isn't code. These are more mainly used for notes sort of situation. You can have block comments, starting off with / asterisk or star, depending on who you ask, and it makes this auto block, and anything within these two anything within these two sort of slash stars is gonna be commented out. See, it's all gray, and the compiler will ignore that pretty much. You can also comment out individual lines, which are pretty useful if you're just trying to skip over a line or see if it's a problem, make a quick edit or a quick note on something. See, like double slashed out that. Up top to bottom, you have include statements. Include statements are generally libraries that have already that are already in existence. It makes things a lot easier, obviously, if you don't have to go back and create code from scratch every single time. Right here, this CSTDLIB stands for C Standard Library. Since we're using C++, that's sort of vastly required. Another include statement we're going to make is IO stream, which is stands for input-output streams. That's how you can read information into the computer and post information out of the computer. You'll see this using namespace std. That's sort of I don't know if I want to. Okay, so what I will say about using namespace std is that this is a prefix to certain lines of code. so that if you have multiple versions of the same thing, it knows which one to choose, which might seem to be kind of a confusing and out of place for this first lesson, but if you noticed it there, that's sort of why it's there. I'll get into that later, obviously. This int main is sort of the starting point of the actual program. Check my notes. Like I said, IOStream was all about input and output. Inputs are generally read with cin, followed by this double less than symbol. Outputs are cout, followed by the double greater than symbol. And that's just sort of a, whenever you go to read output, say output, if you try and read in something that doesn't exist, you'll get a problem. If we just go up here, oh yeah, there are keyboard shortcuts for just automatically running, or you can click this button. It says that the tool shortcut is F6. If you want to press F6 or if the button personal choice, they do the same thing. So it just goes through this random whatever, build failed. I bet that I got the arrows wrong. So shit, not boding well for this one. Makes me look kind of stupid. Re-preface in saying I haven't actually used C++ in a couple years. I've been programming mainly in Java, and it's sort of a different situation. But as you see, the code, whenever we ran the project just said little output. So to sort of correct myself earlier, if you want output, it's the double less than sign from cout. A lot of people, well, not a lot of people, depending on who you talk to, they have cout and cin can actually be referred to as sin and coot. It doesn't really matter as long as you know what people are actually talking about. It's sort of a pronunciation type situation. Its proper name is cout, but if you know it as whatever, that's probably what you're going to call it. Moving on, there are different, whenever you try and execute a program, there are a lot of different situations. You can see here, not a good example. So there are different data types. That's what we'll start with, data types. There are Boolean, example. Boolean attributes are pretty easy. They are they can either be true or false. They only have those two single quantities. You'll see if something is a basic data type, it'll normally blue out. Well, no, because return's not a data type. If the program sort of can guess, there are certain programming terms already in existence, and if it blues out, it means it's probably already, it exists somewhere within the files. And tangents. That was a huge one. I go on tangents sometimes. Hopefully it doesn't bother you. It probably will, but whatever. So if you can just also do things like outputting variables. Variables, I can't remember if I said this. If you're going to basic description is example is a variable. Boolean is a data type. What is a data type? It is a type of data. Obviously, no. But, well, it is, but that's not a very good description. Basically, whenever you have a data type, you programming. Let me switch to. Whenever you're going Boolean, it tells the computer, hey, there's this little space of memory in the computer right here. What does this bit represent? It represents a Boolean value, which is either a 0 or a 1. Different data types have different amount of storage requirements. So if you want an integer, it's going to take a lot more than just a single bit. Since Booleans are only true and false, they're only either 0 or 1. 0 being, what was this just outputted? 0 is false, 1 is true. So this takes up a little space in this example of a Boolean. Boolean data types. Their integers are sort of another simple type of data. We'll call it just an integer a, and we'll set it equal to 5. Output a, and you can see that what's going to happen is, as you guessed it, well, probably not, it'll, as you may have guessed, it'll output the number 5. Yeah, running a little slow, whatever. Okay. You can also, I don't want to say you can also do this, sort of an example, well no, I'll hold off on the example situation. The next basic type of data is a character. You can generally, their equivalent in the real world would be an actual single letter of something. They're normally denoted by these single quotes. That's how you know it's a single character. There are some, like this is a character, that's the new line character, and /0 is the null terminator character. I'm probably not going to cover them at the moment, but it's sort of even though they are more than one sort of letter wide, I guess you'd say, it's still, the computer still represents it as a character as opposed to a group of characters. And you can output letter like that. And you see it outputs the letter A. And to move back to the example, as I was talking about before I introduced the characters, is whenever you try and assign a variable in your program, what will happen is the computer will look up space and allocate bytes based off of the type of, wow, that's really bad. That's supposed to say bool, but it'll allocate bytes based off of the type of data. Meaning that I forget actually how big the number that integer can store is, so I say it's really big and it'll do for most of your situations. But so you have an integer here, and the integer will represent a group of bits, because if you only have a single space in memory, a lot of us use 0 through 9 because we use a base 10 number system. Computers don't have that. They use a base 2 number system. That's why it's called binary. All it is 0 or 1. Sort of a 0 represents a 0 bit, 1 is a 1 bit, and 2 is actually 0, 1, 3 is 1, 1, 4 is 1, 0, 0. Hopefully you see the pattern. If not, we might have to go in a little more in depth as to explaining the binary type system. But so basically an integer says a certain allocated, this string of bits represents one single thing, and it's a number, as opposed to a character. Why I say as opposed to a character is sort of the way that its programming language is set up is that these three, I don't want to say they're interchangeable, but you can use examples like like example, you can set A equal to an example, and you can do this because the Boolean example value false has the value of 0. See, like if you run cout example, what's going to happen is it's not going to output 5 because you just set it equal to false. how can a number be equal to false? It's because false is represented by a single bit that says 0, so that it takes that 0 and sets it equal to that. Another example is, oh wait, no, got a little mixed up. The real example, this is going to show the exact same thing, but previously I was outputting the original example variable. Now I'm outputting a, and you can see that it's set it. There's nothing in here that explicitly sets a equal to 0, but it is because we set a equal to the example false. You can also set you can also say a equals a letter. That's because, once again, it's just a string of bits. The data type lets you know what the bits actually relate to. See, the character A actually has the number 97 representation. If you want to know why it's 97, you should actually pull up an ASCII table, basically because of how slow these are. Well, no, how slow my computer's going. I don't want to chance it bringing up internet browser with me because I don't have an ASCII table anywhere within reach to show you. But yeah. There are also simple operators. Well, moving before operators, an important sort of thing about integers is that they only represent whole numbers. Say you want to try and have 5.5. If you run this, you can see that it'll only output 5. But the reason is that it truncates. If you don't know what truncates, it means essentially it chops off everything after the decimal, because that's what integers are. Integers are only whole numbers. It's 1, 2, 3, 4, etc. So it doesn't like fractions at all, and that's sort of where the couple other data types come into play, like float. A float is a slightly bigger version. There are more bytes that exist for a float than there are for an int. And you can say b equals 5.5. If you try and output b, it'll actually output 5.5, which is nice, because, well, it's depending on your situation. A lot of times you won't actually need fractions, and in programming, it's generally to keep things as short as possible to optimize things. You don't want to, like, perfect example is this video. It's my compiler is running super slow because I'm recording a video whilst I'm doing this. It's not exactly as applicable of a situation, but it's more of the more things that are going on and the more memory your computer's using, is the slower it will actually end up going. Alright, cool. I can't hear that. And there are also doubles. Doubles are much bigger than, well, I don't want to say. Doubles are essentially one of the biggest data types that you'll want to. Doubles are used generally for really, really big numbers, numbers that are a lot bigger than your normal integers. And they can also be decimal points. That's the reason I shifted from float to double. It really doesn't matter. You can play with it, try different values, and see what works. Moving on. Operators. So, obviously there are different situations. You can call it integer b. B is equal to a plus 1. We'll get rid of this 0.5, make things easier. Basically, once you have the variable, you can add to it, subtract to it, multiply and divide, or your basic arithmetic operations, and they're also the basic. Yeah, that's how you modify integers if you want to. You can, if you had a third integer, yeah, I already stated how you could set one equal to 0. Well, you could set an integer equal to a boolean. So you can actually add, say you want to, well, yeah, and I showed you can also set an integer equal to a letter. You can actually say, you can add variables together, and that's sort of a convenient situation. So if you output B, what'll it say? Let's find out. Obviously, what was it, 97 I think it was earlier. So 97 plus 5 is 192 for anyone who did not know how to do simple math. Moving forward, another little interesting caveat would be if we shift the data type of B to being a character, is that you can also apply a lot of different operators. Well, no, you can apply a lot of the same situation. See, if you didn't realize this, 5 plus A is equal to F, which I think is the fifth, A, B, C, D, E. The fifth letter of the alphabet is actually E, but you're starting from the first letter of the alphabet, 1, which means you get F, the sixth letter of the alphabet. Haha. Sort of because each letter of the like the way ASCII values are set up is that they're in alphabetical order. So that we stated A was 97, so B, the letter, the character B, would be 98, C would be 99, etc. Operator, the module operator, I was going to cover that, was change this back to an int and make this a better example. We'll say 20. The module operator is denoted by this little percentage sign on there. If you A module 5, what it'll actually do is it'll divide and then take the remainder. So I guess we'll wait for it to output before I explain it. So A module 5 is 0. And the reason module 5 is 0 is because 20 divided by 5 is 4, and there is no remainder. Say you're going to divide by 6. 20 divided by 6 is actually 3 1/3. And but 20 module 6 is going to be 2, I believe, because it takes the remainder of sort of the. Did it not? I must have forgotten the. Yeah. It takes the remainder after the division, and that's actually pretty useful. One of the little caveats you'll use to determine whether an integer is even or odd is you just module 2, because if you divide any even integer by 2, excuse me, sorry, keep stumbling over my words. Every even integer is divisible by 2, so A module 2, if A is even, will always end up being 0. If it's odd, it'll always end up being 1. If it's not an integer, then you get into a bunch of weird situations where hopefully it's not an integer. But no, it doesn't necessarily work if you have decimals, because things get weird. So those are the basic operators. Moving back, we actually, I skipped over cin to make a better example of everything else. But cin is simply, once you, cin takes the next available input from the keyboard, well, provided your keyboard, well, your mouse is in the right place to select that the input's actually going in there. Now, I definitely should have just moved that line. Okay, so since we specified b as an integer, remember there are a couple situations. I'll give you another example of this. Okay, so it runs up, the computer asks for our input. 7 is the number we will choose. If you hit enter, it returns 7 because that's what we told it to do. It's a very simple program, but that's exactly, yeah, this is lesson 1, so hopefully you weren't expecting much. Another thing I was saying earlier, if you input A, it'll output 0. Oh, that's weird, because it's trying to read in. Well, there you have it. I guess it's sort of, if it's an invalid input, it automatically goes to 0. That's interesting. I was expecting it to say 97, but shows what I know. Doesn't bode well for my skill set. No. Hopefully you realize it's, while I have been programming for several years, everyone's bound to make mistakes. Since this is working with computers, it's as simple as backspace or delete. And you just fix whatever you want to fix. Yeah. So if you try and input, if you try invalid input, it looks like it'll just read in 0 as a value. Let's try this for real. If you just mash on the keyboard real quick and hit enter. Oh yeah, I don't think I stated that I have to hit enter, but you should hit enter after. That's sort of how it knows to officially read in whatever that you're done typing up the input. And okay, yeah, that's video's on 30 minutes now, so that's really huge. We'll take a. This will be the end of. Yeah, we'll take a break. This will be the end of lesson 1. Moving on to next, I feel like I'll probably explain functions. Once you know what functions are, we'll move into what structs are, and then arrays and pointers. So hopefully, hopefully you already knew everything I was about to tell you, and I was just trying to make things a little simpler with the explanation. I was really hoping I would make a better diagram, but once again, the reason for data types exist is because of the binary system. It's hard to exactly tell a computer, hey, this is a number, or hey, this is a character, because everything is represented as a system of zeros and ones. I guess sort of the main thing I was trying to teach with switching back in between these things are that is exactly that the hardware just represents everything as a system of zeros and ones. I guess, yeah, I don't really have anything left to say on the matter. So stay tuned for lesson 2. It'll be up. I don't exactly know when. We'll see.